Okay. CompactLogix training hardware consists of a CompactLogix PLC, which is that right there. A point I/O rack or chassis. That's this guy down here. 1734 point I/O. It is Ethernet based. A PowerFlex variable frequency drive or VFD, which is this guy down here. An Ethernet switch, which is this guy down here. A panel view 600 operator interface terminal or OIT, guy up here. An array of switches, indicator lights, down there. And CompactLogix I/O.
So since the I/O rack can move away from the physical PLC, is it usually beside it in the cabinet or is it somewhere else?
It may be in a completely different building. That's the beauty of remote.
Yeah, that's why I asked.
If you have a big machine with lots of I/O on it, someone's doing process control or, whatever it is. If you have the central controller and then, it's lots and lots and lots of I/O, rather than running separate wires to each individual input-output device all the way back to the main control enclosure. If you put remote I/O out in, strategic places, you've only got to run the inputs and outputs to the remote I/O, and then a single Ethernet cable goes back to your control enclosure. Okay, so it simplifies wiring in complex environments, or if you got to go really far, like you have your central controller here, and maybe you're controlling the level in a tank that's 100 yards down the way. Instead of running all the signals back and forth, you just put one I/O rack out there and Ethernet cable back to your controller. Good question, by the way. So, CompactLogix trainer, again, number one is the CompactLogix PLC, where the one is, that is actually the power supply. The PLC's there. Okay. Two is the panel view. This one is specifically panel view 600. Unfortunately, we don't get into panel view in this particular class. We don't have time. If the semester was, 18, 20 weeks long, we could probably do it, but in 16, it just can't be done. The point I/O rack, the Ethernet switch, VFD, and then inputs and outputs. So here you got the CPU is A, power supply is B, discrete I/O module is C, and analog I/O module is D. It is in fact I/O, not just I or O. These are combination modules. They do contain both inputs and outputs. If you only need a few inputs and a few outputs, rather than purchasing two separate cards, one for input, one for output, you just get a combo module and kill two stones with one bird. There are 4 relay outputs on that discrete module. Relay meaning that you can switch pretty much any voltage you want with it. It's not restricted to 110 or 24 or 12 or 5 or any other common voltages. The beauty of relay is if you have the correct card, you can just use it for switch closure where there's no voltage applied to it at all. These, all four of the relays are tied to a single common terminal. So whatever your common voltage is common to all four of them. Okay. 6 inputs on there, they are in fact 24 volts DC. We are wired for positive logic, meaning that you have to have a plus 24 volts on your input terminal in order to get a 1 in your input database. That's something else we got to get used to. In 500, it is a data table. In 5000, it's a database. And then same thing with the analog module. It's 2 analog in, 2 analog out. Unfortunately, the analog devices on these trainers quit functioning a long time ago. So we're not going to get to do anything with analog. And, which we could, but the equipment won't allow us to. Panel U 600, 6-inch color touchscreen, OIT or HMI. I think I told you guys this before, HMI is much too generic of a term. This, what I have in my hand right now is an HMI, it's a human machine interface. I'm a human basic machine that uses the interface between us. Okay. The point IO, there is the power supply / network adapter. There is a thumb wheel on there that you can't see in the picture. It currently says 002. If you want to use DHCP to set the IP addresses of all your components in your system, which is not a good idea, by the way. You set that thumb wheel to 999, and that tells it use DHCP. If it's anything else, it is whatever that particular thumb wheel setting is, will determine what the 4th octet of the IP address is on that module. By default, all Rockwell devices are set up for DHCP and or BootP, depending upon what it is, but if you're going to go static, it's always a Class C subnet. It's in subnet number 1. 192.168.1 dot whatever. Okay.
This is for, what was it? Words just fell out of my mouth. Anyway.
Hey, man. So anyway, the thumb wheel is set 002. It can be anywhere between 000, which is reserved, and 255, which is also reserved. So anything from 001 to 254. So anything else is, other than 999, is invalid and will complain. If you guys recall from last semester, each one of our PLCs, VFDs, whatnot, had different IP addresses. So you connect them all together and make sure that you were connecting to the correct controller. We had a few instances where somebody downloaded their program to somebody else's controller. Of course, I harped on you guys for 16 weeks, do not download the BootP program to your controller. Big sticker on each one of the trainers, and at week 16, we still had people download the BootP programs. Shows you how well everybody in this class listens. You were just learning then. This semester, if you do anything that I say do not do, I'm going to be much less lenient about it. Okay? If I say do not create program tags, only create global tags, which at this point I think I beat that horse to death. and you end up creating program tags, you're going to start over. Don't just fix it, move on, but you're going to start completely over. Not only is that my rule, but that's Rockwell's rule. If you create a program tag instead of a controller tag, that goes against what I said, but you cannot just change it from program tag to controller tag. Software won't let you. Oh, well, I just create a controller tag with the same name and move on. You can't do that either, because it's always going to default to the program tag, not the controller tag. Nate.
Is it possible, in instances like this, to make a copy of the program and then change the copied program?
Nope.
Wow.
When I say start over, I mean start over.
Oh.
Oh, so if I was working on the same project as someone else and one of us screwed up, we both had to start over.
Wow.
If you're working together, yeah.
So
It's a good thing we each got our own PLC.
what's the value behind the program tag then if it screws things up that royally?
If you need to do the same thing in multiple programs, if you're using program tags, you can use the same tag in each program because it doesn't leave that program. So you're trying to control the level in a bunch of tanks or, you know, whatever. Instead of having to say tank 1, tank 2, tank 3, tank 4, tank 5, it's just tank high, tank low, whatever. Okay. The problem though, whenever you're talking about program tags, is you cannot use them anywhere else except in that program. Which means you cannot send the data about that bit or whatever it is to an OIT, to a data historian, produce a tag that another controller can utilize, any of that stuff.
So it's just permanently locked down to that one program?
That one program, yes. We are not going to be doing produced and consumed in this class, because we can't. All the controllers are on the same IP address. You try to plug two trainers together and they'll both throw an IP address conflict and fault out the controller. Makes it a lot harder for it to do things whenever it's faulted. PLC3 you do get into it, but you're using the CompactLogix trainer and the CompactLogix trainer together to do that. What I'm trying to get you guys in the habit of is always create controller level tags, unless you specifically need program level tags to get you into the habit of doing that. The vast majority of the time, you're going to want to do control level tags, even out in the real world. Sage.
So you say you can't go from a program to a controller without restarting over. You go from controller to a program without having to restart stuff.
All you have to do is create a program tag with the same name. It'll always prefer the program tag over the controller tag. I won't ever tell you to do that either. Anyway, the IP address of the PLC is .7, so I'm sticking it on the front of it. The point rack is .2, so a sticker is on the side of it. It's this.
Yeah, I got a camera.
Right down there. The OIT is what, 3? 9. I was close. And the VFD is 5. And so when you go to download the program to your controller, invariably going to get asked, which one's the controller? Well, it's probably the one that's got the same IP address as the sticker that's on the damn controller. It's also the only one that's got the same model number on it. It says L36ERM right there on front of it. Can't miss it. You just got to read it.
Reading's hard for some people.
Okay, so now that I'm finished with my rant, A is power supply /network adapter. B is 8.24 volt sinking input. That's this guy. We did not go over syncing and sourcing in LC1, did we? Briefly? Okay.
Just briefly.
If it is a syncing input, means it runs positive voltage. If it's a sourcing input, means it's running negative voltage or 0 voltage. Wow.
Is that PNP and NPN?
Mhm.
Okay, all right.
Yeah, PNP would be positive, NPN would be negative. It's easy to remember because the letter that starts with P is positive, N is negative. Okay?
So I noticed that both the actual CompactLogix PLC, the CPU, if you will, and the what was it called? The point IO rack remote. They both have their own power supplies, whereas the trainers from last year seem to only have one. Can you remind me what the reasoning behind that is?
Because you only need one on the 500.
Yeah, I guess you'll just need two on the, or two, yeah, two on the 5,000.
Mhm.
Oh, okay.
The power supply on the CPU powers the CPU and any local inputs and outputs.
Mhm.
Anything that's not physically connected to the PLC, that's powered separately.
Oh,
If this remote rack is in a different building somewhere,
oh,
put a
okay.
power supply local to it, then all you gotta do is run the Ethernet cable. Now,
Yeah, okay. Now that makes better sense. Now I understand. Thank you.
So those modules like internally daisy chain to each other?
they're on the same address bus, you know.
Okay, yeah.
Okay, so on the side of these, that side tells you all about which firmware revision it is and all kinds of other nifty information, like model number. When we go to assign our I/O in our programs, we're going to need this information. Okay. If you just say that it's a 4-point syncing input, that's great, but there's more than one kind. You have to tell it what the part number is, model number. There's also multiple firmware revisions that may or may not be compatible with each other. So you have to tell it that so the controller knows how to talk to it. Okay. On the other side, can't see it very well, but there's a little clock here. It tells you what position that little pin in there needs to be in. What it does is very cryptic, very complicated. We're not going to worry about it. Just need to know that the module itself tells you what position that pin needs to be in. There's a mating socket on your I/O rack down there, or down there. You have to turn it to the same position. It's actually functioning as a switch down there, which tells it how to interact with this module. At least one of the pins on this module is probably different from what the pins do on this module. You see that the schematics on them are different. Okay. The clock position is also different. But syncing input module, 8-point syncing input module. Went the wrong way. Okay, the next one is a 4-point sourcing output. Syncing on input tells you positive voltage. Sourcing on output tells you it's positive voltage. Okay, when you turn this output on, it's going to give you a positive voltage. In this particular case, it's 24 volt module, so you're going to get 24 volt DC output. Next one is 2-point analog input. 2-point analog output. Very high speed counter. The high speed counter, almost through that picture. And then I saved your life. Wasn't it nice of me?
Yeah.
High speed counting module, if you have an input that switches faster than your program scan, use high speed counting. You go in a pulse coder for water meter, flow meter. You know how much water passed through the meter over a certain amount of time. And you're getting pulses faster than your program scan is. Then you use high speed counter because the high speed counter keeps track of how many pulses it is. And whenever the controller does its program scan, it says input scan. Hey, high speed counting module, how many pulses have you counted since the last time I asked you? And then that updates the data table or database and goes on about its business. As it's doing the program or input scan, program scan, output scan, housekeeping, this is still counting pulses. When it comes around the next time, hey, high speed module, how many pulses have you counted since the last time I asked you? Thank you, updates goes on. Okay, that's why you use these. Hold on just a second. That slide used to say this was blank. It is not a blank module, it is a power module for the high-speed counter. These two you have to put together, they will not function by themselves. This is just power module, so it doesn't do anything except supply power to the high-speed counter. Without the additional power supply, the high-speed counter doesn't do anything either. Okay? That's why you notice that they're both purple.
Ah.
If you look at the side of them, they also have the same part number because they're sold as a pair. Okay. Isn't Nate?
A little question about the program scan and about the high-speed counter. I recall that back in last semester, the way the 500 did a program scan is that it would read the electric pulses from the components and register that as ones and zeros on the data table. In this case, it's kind of doing the same thing, but instead of a data table, it's a database.
Exactly the same thing.
And the reason why you want this high-speed counter is because if the pulses are faster than the then I take it the PLC without the counter. If those pulses, those electric pulses, are faster than the actual scan cycle, it's not going to be able to put that data on the database, which is why you need that counter.
Exactly.
Ah.
And if you remember, in order for it to see that it changed, it has to see it go from a low to a high. That's a transition.
Mm-hmm.
It needs to go from a high back to a low to reset it, and then from that low back to a high. So it's actually, if it's switching faster than 2 times your scan cycle.
Okay.
Because the way, the controller doesn't know, nor does it care how many times the input has turned on or off while it wasn't looking at it.
And it keeps counting even as it continues on.
The high-speed card will continue to count.
Okay. I take it wouldn't continue counting if the high-speed counter wasn't there.
Yeah, if your input's turning on and off faster than 2 times your program scan, you'll never see the transition. You'll never see the turn off or on.
Okay. All right.
Any other questions?
Not for me.
So basically, the database essentially does exactly the same thing as the data table did, in PLC one. It does exactly the same thing, different name.
Essentially, yes.
I actually do have one more question. There is probably a defining difference between a data table and database. I cannot recall, what that difference was. Can you remind me of that?
Terminology,
Oh,
and that's effectively what it is. They're both memory locations that store data.
it's just called different, okay.
Colloquial.
The way that they store the data is a little bit different, but all we need to concern ourselves with is that it's storing data.
Okay, that's nice. Thank you, Alice.
Number 5, PowerFlex 40 VFD with Ethernet adapter. If you don't have the Ethernet adapter on it, it's flat face instead of looking like it's pregnant. Like it is. And the lights that show port status and whatnot aren't there. There's not doing Ethernet. It doesn't have to be Ethernet. It can be a Profinet, DeviceNet, a couple others, but they make adapters for the 40. 8-port Ethernet switch. Most of the controllers have 8-port switches on. I think all do. Some of the switches look a little different than others, but they all perform the same function. They're just dumb switches. I've already gone through and plugged in all of the Ethernet cables into everything, so you guys don't have to. But it does not matter which port, which device is plugged into. It's just a switch. It's going to say, hey, when it does, from those of you that have had the 111 class, when it does its ARP, hey, who has this address? I do. Okay, well, that's on port 3. I know, thank you. So I'll always send data for whatever's on port 3 out that port.
So if there's like 4 different fanning drives for the access on a robot, it goes, each one of those go into a different Ethernet port.
They're not Ethernet.
I'm closing this so I can talk about it.
She was annoyed.
Sorry. I'm projecting so that everybody in the room can hear me.
Makes sense.
And then the actual HMI, machine interface, push button pilot lights, around here on the lower right. You have the ones on the top here. It says 1769 IQ6X OW4. If you look at the module, that is the model number on the module itself. So these 2 lights are hooked up to digital output 0 and digital output 2. Okay. This also says IQ6X OW4. These are a push button selector switch. They also happen to be illuminated. You control the light separately from what the switch contact is actually doing. So that's why it says DI0DO1. Digital input 0, but it's also digital output 1, and so on. These guys are hooked up to the remote, the point IO rack. Okay? So I have a different part number. They're not combination modules, so there's a slash between the part numbers. Okay. Again, only outputs illuminated input, so it's input and output. And for whatever reason, they put those 2 on there, marked them as spare. They're not wired to anything, completely useless. Don't do anything but take up space. We can't use them. Analog numeric number display. It's actually supposed to be wired into the analog module. It is, but the display itself doesn't work. And the potentiometer that's on there is wired into the same analog module as an input, but the Potential hours are off right, so they don't do anything either. That's why we won't be able to get into analog in this class.
Are they just like well loved or have they always?
Very well loved.
Oh,
Now, these trainers are almost as old as you are.
okay. Weird.
Setting up the training equipment, making the appropriate connections, they're already set up, they're already connected. The connections are supposed to be as follows. Let's say your trainer's Ethernet switch. From the switch, there's a cable that connects the switch to each of the devices in your local network. It does not matter which cable is plugged into which port, as long as all are connected. Connections are as follows. I'm not sure why they're labeled 1, 2, 3, 4, but that's not necessarily the ports they're plugged into on the. And then, power supply is down here, 120 volt. There's a switch directly above it. Turns power on and off. Okay. You'll also notice that these do not have lockouts on them like the ones in PLC 1.
Oh, that's.
Okay. I still want you guys to turn them off at the end of every day. I did go through and replace all the batteries on the OITs though, so they can quit complaining about low batteries. I've got an error on my screen. So I eliminated that. I just replaced the battery. I also put a default program in there so you can see the status of your inputs and outputs that you're using. You'll see when you power it up. It's kind of cool. Power supply does have surge suppressor on it. There's also two banana plugs down here that have plus 24 and 0 volts on. So we're not going to need it. We'll show you if you need it, it's available. Also a fuse down there. If that fuse blows, nothing works. Okay. Keep that in mind whenever we start going troubleshooting. Then you make the final connection with an Ethernet cable from the Ethernet switch to the PC. That connection has also already been made for you. You may now power on your training demo. The indicator light should illuminate at various places on each of the devices, indicating that they are powered. The analog cards are from the flash red. Ignore it. The one on the point right, not flash. Just means there's no connection. I don't see a voltage or a current signal or whatever. You have to ignore it. Doesn't mean anything.